everyone, today I'll show you how we can create fixtures in Tebis. Before we get started, I have separated my part into different folders. So I'll put all of my contours in here. This one is going to be my main part, and I have put all of my extension of my part along with my cover surfaces in one folder. I have also created this folder, I called it LSeat. Later on when I create my fixtures, I would like to save them all under this folder right here. Now to get started with everything, we do have here the laser cutting module, and we do have the LSeat function where we'll be able to create fixtures in Tebis. The first thing you would like to do is to specify the different types of components. When it comes to the product, it's going to be the main part, so I'm going to select my main part here. You specify your extensions. Here's my extensions and my cover surfaces. The wall thickness is going to be the thickness of your part. Mine's going to be 0.8. And the contour is going to be the contour of my part. Now that we have told it exactly the different types of components we have, we can move on to the next step, which is going to be these tensions. So here we do have a few options that we can customize and specify how you would like your fixtures to be created. The first is going to be here the thickness of your stanchions. It's going to be the thickness of your raw material you'll be using. You can select a slope depth if you want, and that's going to be the distance between your part and your base plate. If you do leave this option at 0, it's going to be created exactly halfway through. Otherwise, you can customize it if you'd like. We have here some gap value. If you'd like to leave that, it will leave a buffer or room between the intersection stanchions. You can select the corner radius. That's going to be the radius that you can customize of all of the sharp edges of the stanchion. That's going to be rounded outside of your part contour. So if any stanchion will come up outside of your part, you can round it up based on a corner radius. In this case, I have selected 2 mm. Next, we do have the relief R2, the relief R1, and the relief angle. All of this is related to the relief cut or the notches that's going to be created on your stanchions. I do have here a picture that's going to explain this a little bit better. So the R2 is going to be this radius right here of your notches. This one here is going to be the R1, that's the radius. And the relief angle is going to be the relief angle of that notches you're going to be created for your stanchions. For now, I can select it 1 by 0.5 mm by 45. And next we do have the base height. So when it comes to the base height, that's simply going to be the desired height you would like to specify, and that's going to be calculated from the lowest point of your part over the base plate. Now, we do have here the side shape, angle and straight. Here is going to allow you to either create stanchion that's going to be progress on either an incline from the part edges if you leave it at an angle, or you can always set it to straight, where all of your stanchion will progress straight perpendicular from the part edge of the area to the stanchion base plate. This option can be very well suited if you're going to be using material thinning, and of course it's going to result in a very stable sections if you do so. I can leave it for now as an angle, and then here we do have few options specified to the contour relief. So here's going to be based on the direction, the position, or the shape of your contour relief. You can have it either set to normal or vertical. Normal is going to come executed in the normal direction of your trim contour, or vertical is going to be executed vertical to your active axis system. For the position, you can have it either sidewise or center. So either it's going to be really side driven to the selected contour if you leave it to sidewise. Otherwise, if you set this option to center, it's going to be vertical to the, it's going to be center driven to the selected contour. The next one up is you can customize also the shape of your contour relief. You can either have it round or angular. If you set it right now to round, they're going to come as semicircles. Otherwise, if you set this to angular, they're going to come as a rectangular. And here you can specify the depth of that contour relief and of course the width if you're going to go with the angular option. And here is going to be the width of the angular relief you'll be creating. You can also specify the position of your stanchions. If you do have this option set to grid, enabled, what's going to happen here is it's going to create or automatically generate the tensions in a defined grid based on the distance x and distance y. So for now I have my distance x set to 150, and that's going to be the distance between the center of the tensions in the x direction, and this one distance y is going to be the distance between the center of the tensions and the y direction. If you do have some tension that you would like to, let's say, modify freely, you can have them enabled, and you can always do it automatically later on in the interactive menu. And this one here is going to allow you to select linear curve, so you can specify freely defined tension in an arbitrary location. If you have these two options set to 0, an example, distance y is 0, distance x is 0, what's going to happen here is the grid selection will not be calculated, but you can also customize that later on in the interactive menu. So as of now, we'll set this to 150, 150, and then we can move on to the next one. Here you have your base plate. If you set this to auto, it will auto calculate your base plate for you. Otherwise, you can always have it based on a selection menu. If you do, you're going to have to generate a planar surface or planar face that's going to be perpendicular to the active system. Otherwise, if you do not wish to create a base plate, perhaps you do have a machine where all of your tension is going to be based on the machine plates, then you can set this option to no. Otherwise, you can leave it to auto, and you can customize your relief cuts as well here. Here we do have the ribs and slot. By default, this option calculate is enabled, and if so, it's going to calculate all of the notches and the ribs and the slots for all of your plates. And here we do have the option on how you can customize the height. And here is going to be the height, of course, of your ribs. The width here is going to be the desired width for all of your ribs. And you do have distance x, distance y, and oblique distance. And those going to be the distance between two ribs, either in the x direction or in the y direction. Or you have the oblique distance that is going to be the distance for angle direction between two ribs. You can leave also a gap value if you'd like. It's going to be like an air gap you would like to leave between the ribs and this tension and the notches of the base plate, if it is applicable to you. Otherwise, you can set this option to 0. And you have the relief R2, R1, and the relief angles. This can be again the radius that you're going to be creating. The relief cuts for the ribs of the tensions. The last one here is going to be the configuration. You can have labeling for your tension and your base plate, and also you can customize your font size. As a note, 8 is going to be the minimal or it's going to be the smallest font you can use. Otherwise, you can make the text bigger, or if you don't want to, you don't have to label your tension or your base plate. Otherwise, you do have the capture grid and the colors where you can customize your visualization of everything. An example here, if you would like to change the color of the tension Y, you can choose any color from 1 to 130, and then it can be the new colors for that tensions in the Y direction. Now, before we get started and select start to calculate our fixtures, I would like to point out that we do have two options here. We do have the save. If you would like to save all of this configuration of this fixture, an example, you can save it as an LSeat file. I can say, for example, this is going to be fixture 1 or fixture, let's say 6 millimeter. And once you save this, next time you're going to load a different project or a different part and you'd like to use the same configuration, all you have to do from here is load that fixture 6 millimeter or this one right here that I have created, and basically you can skip all of these steps and you can hit start to start calculating your tensions. Now once I hit start, as you can see here, I'm gonna turn off this menu for now. You can see that my tension has been calculated. You can see the colors, the green and the orange and the X and the Y direction. And here you do have the position where you can delete extensions. You can move extension, for example, I can move it around. Or you can move it based on a copy. So if I enable this copy function, I can leave the original in place and I'm simply moving the copy of that sentence. You can also insert a new sentence if you'd like. It will have to be freely drawn, based either on a curve or a point to point, but that's a possibility. Now, once you hit next, it's going to calculate the connections between your sentence, and also it's going to create for you the base plate, since I have that set to auto. So you can see right here, this is my base plate. You can see if I go now to wireframe, you can see that my slots, my ribs between all of them. And if I would zoom in here, like we selected earlier, I set this value to 0.5 millimeter for the R2, 1 millimeter for the R1, and you can see here it's gonna come at a 45-degree angle. And all of these options, again, it can be customized here in Tebis. To enable back my shaded view, you can enable the cuts, where you can thin your extension materials, either by using like a polygon, a circle, or let's say a rectangle, or otherwise if you do have a curve already pre-made, you can use that curve and then you can apply it to any elements you'd like. To use this as an example, perhaps I can go with a circle. You can choose first, let's say those two elements, maybe even the third one. You can customize the diameter. An example, I can say 25 millimeter diameter, and then you can give it the position of those circles, and it will create the cut for you automatically based on the position and the diameter that you would choose. Otherwise, we do also have this option that's called offset in the cut, where it's going to thin your material based on an offset value and a radius. So I can simply select all of my extension here on my part. I would like to make my extensions lighter, and I can leave the offset to 5 by 1 millimeter radius. And here, if I hit apply, it's going to calculate all of your extensions one by one, and once it's done calculating them, it's going to create that offset that I just applied here based on that radius. And you can see right here I have thinned my material very nicely, and it's going to be much later on manufacturing side of things. Now once you're happy, you can select next, and now you can see here, if I give you guys a center top view, you can see that all of your extension has been created, and you can arrange them right here in Tebis simply from the LSeat function in a way where you can nest them or pre-nest them based on these three movements. You can either move, you can rotate, and you can also flip the extensions. An example, if I would select this one, I can move it around and I can try to nest them based, of course, on a plate that I would like to do. Otherwise, in Tebis, we do have an option that's called all nest, where you can nest all of your extension that's been created right here from this option. Another one here in the arrange function is we do have the rotate. An example, I can select this one right here, and I can rotate it based on an angle. And you can customize this angle right here. Let's say if you wanted to do 180 degree, you can. Or if you'd like, you can flip that one either based on an axis or the x-axis or the y-axis. So here based on the x-axis. Otherwise, I can use my y-axis and I can flip it around for better nesting. Now, once you're happy with everything, all you have to do is select next. And you can see here how it's going to save everything for me based on a different folder. Now, I have created that LSeat folder, but I also created assembly, contour, volume, development, and a setup folder underneath. So I can go here to the contour. I can have them all saved under LSeat, or I can customize it. I can go down here and I can say assembly, save it under assembly. Or I can say here the assembly, I can save it also under my contour if I'd like. For the volume, I can save that under my volume folder. So everything will be organized, and later on when I'm working on my nesting, I can see everything very clear based on these folders that I have pre-made. And my setup, I will send it in the setup folder. And now all you have to do is select OK. And now everything's going to be pre-saved for you in your LSeat folder that I have created right now. And now my fixtures is going to be ready for nesting. You can see now. If I'm going to close up this window, you can see everything under my assembly, everything under my contour, everything under my volume, my development, and my setup. And that's how we can create fixtures in Tebis. Now next I would like to show you how we can able to modify the shape and the dimensioning as well as the position of a geometry straight from the NC job. So right here we're going to take this part as an example, and I have already created a new laser cutting NC job. So right here I have already specified all of my machine geometries, my tool, my path, and as well as my connection. And all I have to do right now is to hit start. You can see right here for the very first geometry, you can take this as an example. It is a circle. And you can see right here the first menu we have is going to be the area where I'm able to see this option called shape. And I'm able to modify the shape of my geometry either to a slot, a rectangle, triangle, etc. A hexagon if I want to. So here you can see I can change it perhaps to a rectangle. And now once it's done, if I would head to next, I am in the path correction menu where I'm able also to change the dimension of that geometry. I can give it a radius, I can change the length, as well I can change the width of this geometry. Not only that, but if I move to the positioning menu, I'm able also to modify the positioning of this geometry. We can do it based on the relative axis system, and we do have few of those here, but relative to the axis system will be normal to our surface. We'll be able to change the geometry positioning based on the U direction, the V direction, or the W. So an example, if I would like to lift it up, I can give it a negative value, let's say -10, and I can also shift it either left or right. Let's say we can do 2.5 millimeter. And also we can rotate this geometry based on an angle. I can give it a 15-degree angle, and just like that, straight from the NC job, we can modify this geometry very easily. Now once we hit next, simply gonna calculate this job for you, and it will start processing this first geometry. You're gonna see where the head's gonna come in, and it's gonna cut that rectangular and move on to the next. Now there's another thing we can do straight from the NC job besides changing the geometry shape or the dimension, is we can also offset a curve if we would like to. So once you go through the area menu, and if you hit next, straight to the path correction, we're able to offset a curve or a portion of a curve if you would like to. So for example, let me zoom in, and let's say if I would like to offset between this part or that point and that point by 5 millimeter, I'm able to do that straight from the path correction menu. Now first, let's give a restriction to that curve we would like to offset. I'm gonna set this as my starting position, and I'm gonna give this point right here as the end position of that curve. So if I'd like to create an offset between these 2 points, all I have to do is place the cutting head in any point between my starting position and my end position, an example somewhere here. And now I would like to offset it, let's say along the V direction by 5 millimeter. You can see that the head's already offset, you can see it moving. And now if I hit set, you can see easily it created that offset curve for you straight from the NC job. Now all you have to do is next. Now if you'd like to see it run, to cut it, all I have to do is hit play, and you can see that it will start cutting along that offset curve.